So I wanted to take you guys through the Moleville Metropolis, which is the roadmap for stoichiometry. So if you would take a piece of paper and fold it in half, and then this is the drawing that you need. So you got a whole bunch of roads, which are your lines, and a whole bunch of houses or boxes. Okay. So maybe pause it here, draw this all out. So on one side of the paper, you're going to label it as substance A. And then on the other side of the paper is substance B. So all of substance A and these things on this side, these houses on this side are the same as these houses on this side, except for these are all in substance A and these are all in substance B. So the first thing that I ever taught you, the first conversion factor that I ever taught you, went from volume in milliliters. So this is a liquid to mass in grams. Okay. And the road that is traveled by this is your density. So if you're going into the mass, you multiply by the density. And if you go out of the mass, you divide by the density. Wherever you see the divide sign, the value is going to be on the bottom of the fraction. And wherever you see the multiply sign, that's going to be on the top of the fraction. Okay. So the second thing that we can do, so from mass, we can go to mole. So just remember, this is like the mass. This is a weight, kind of almost. It's tied to the weight, whereas the mole is more of a counting number because it's tied to the particle. And then you have volume of a gas at STP. And this is in liters. Okay. Over here is molarity, which is something that we will learn later. And it is capital M, but it's concentration. So we don't need that one yet. Okay. And then, so to get from mass to the mole, we go through the molar mass. Now this is the molar mass of substance A. So again, going into the mole, you divide by, and going out of the mole, you multiply by. The particle here is 6.02 times 10 to the 23rd. And then the volume of a gas at standard temperature pressure is 22.4 liters. Okay. Again, going out of the mole, you multiply. Going into the mole, you divide. And the same thing for volume of a gas. If you go into the mole, you are dividing. And if you go out of the mole, you are multiplying. Okay. So we have this. And then on the other side is the same thing. So we're going to skip the middle road here that connects the two things because we're going to do that a little bit different. This would be B. This would be A. Okay. So then particles, volume. Again, this is milliliters. It's a liquid. Mass. This is molarity. Substance B, which is concentration. Capital M is that. And then volume. Gas. STP. And then this is liters. Okay. So I put in green the things that don't change because it doesn't matter what substance I have. 6.02 times 10 to the 23rd is always going to be the number that we use to get to the particles or to get out of the particles. We know that a mole is equal to that. Half the time we're not going to go through the particle information. And then 22.4 liters is not substance specific either. As long as we have a gas, 22.4 liters is the number that we use. So the green are the ones that we have like, okay, these are the things that we are using. It doesn't matter what substance I have for those. What does matter are the molar mass and the density. Density is substance specific and molar mass is also substance specific. So you have to pay attention to that. And again, we'll talk about this one a little later. All right, so if we are talking about a reaction, okay, and let's just say that we have Cu plus a CuCl2, sorry. We have 3 CuCl2 and plus 2Al, and that forms 2 aluminum chlorides plus 3 coppers. Okay, we can look at this in terms of a, let me see here. All right, so let's say that we have a reaction in which we've got 3 CuCl2 plus 2 aluminums yields 2 aluminum chlorides plus 3 coppers. Okay, we can look at this in terms of particles. So we could say that we've got 3 formula units of copper 2 chloride, 2 atoms of aluminum to 2 formula units of AlCl3. And that's also to 3 atoms of copper. So we could say this, that this would be, this is an interpretation in terms of particles. We could also say that we can interpret this in terms of moles. So if I do a mole interpretation of this, I've got 3 moles of CuCl2 to 2 moles of aluminum to 2 moles of aluminum chloride to 3 moles of copper. Okay, so then this is what we are going to use. These are what we would call the mole ratios from the balanced chemical equation. And this is the conversion factor we use to get from substance A to substance B. Okay, so this is the conversion factor that we use to get from substance A to substance B. So then we can go back up here to our Metropolis. And the thing that we are going to go through here is the mole ratio. This is always going to be the same. It is going to be the moles of substance B over the moles of substance A. Okay, so that is your mole roadmap. If you are going from volume to mass, you are going to have 1, 2, 3, 4 roads that you travel through. So you'll have 4 fractions after you're given. Okay, if you're going from moles of A to moles of B, then you only have 1 road that you travel, which means that you only have 1 fraction that you put in your conversion factor. Okay, so use this, might help you. Welcome to the Moleville.